Good evening, everyone. Good morning, depending where you are. My name is Reginald Menard, and I'm here to present my research on project-based learning. Why is project-based learning important? And why must educators study about it? What is project-based learning? Project-based learning is a way to provide high-quality experiences in education and best example I can give you of project-based learning is when you conduct experiments, when you do activities in science class versus just reading the textbook and answering questions. So today, the research question I have is, does project-based learning help students obtain higher test scores? Is there a difference in test scores when you use project-based learning versus the traditional instructional model? So project-based learning is very important for students to learn real life skills. They acquire how to do project management. They learn how to collaborate just like they would do in the world, in the corporate world, in the professional world. So I have read and looked at many literature reviews that talks about its impacts and how project-based learning has impacted schools, whether it's elementary schools, whether it's secondary schools and post-secondary schools. In my research, I had a treatment group. So the independent variable had a treatment group and a comparison or control group. And project-based learning basically was applied twice during the school terms, which is 2 quarters. And the traditional instruction was also used twice. And then my dependent variable was a unit test after the treatment and comparison groups. To tell you more details about my treatment or the people I studied, so it was 30 students. They were to read a grade level book, and so that's the treatment. That's the treatment assignment. That's the project-based learning assignment. The project-based learning assignment I have 30 students, 36 graders, by the way. And the assignment was they should read a grade level book and reenact the scenes from the chapters so they could get an understanding of the text. For instance, they could know the main idea and the details by acting the scenarios out. So of course you need to do strategy instruction. You have to teach them how to use the project-based learning strategy. And then after they understand, after you do modeling and you give them examples and you act out some scenes yourself, they'll follow you. And then they could go in groups and they could do it. They could become a little casting crew where they have their actors and directors and they could act out the chapters. But you have to also prepare them for that. Now, the traditional instruction is we're going to be using the same 30 students, so it's going to be at different times. And it's going to be the usual reading the book. The teacher can read, students can participate, review questions, take quizzes, and then the unit tests. So we're going to have a unit test after the project-based learning, and we're going to have a unit test after the traditional instruction method. Excuse me. So starting off, to make sure that students are on the same level playing field. I gave a pretest, and the purpose of the pretest was to, since it's going to be a reading assignment, what you can say a literacy assignment, I wanted to see if the students were on the same oral reading, comprehension, inferential reasoning, if they had the same fluency, in other words, if it was equal among the students. And the purpose of this research was to determine whether project-based learning generated better test scores versus the traditional model. So the school had 4 reading assignments, and I used a quasi-experimental design, and I tested the treatment twice, and I tested the comparison twice. So it was done in this order. First, it was the traditional instruction and all the assignments, unit tests, and then I collected the results. Same thing for the project-based learning, unit tests, and then the results. And then I repeat that again for both the control group and the experimental group. So the demographic of the people who were participating in the study. So the local school district has a population of 8,834 students. 5,267 of them are of Hispanic origin. 2,804 are African Americans, and the remaining 767 are, they have a Caucasian, Asian, and people who are mixed. So that was the small group. And the student population is 52% male and 48% female. And I also looked at the district-wide test results for the 6th graders. So 32% of the 6th graders scored at proficient level for the ELA. And for the mathematics, it was 22% that scored at proficient level or higher. The school that is participating, the school I use, has a population of 693 students, and it matched the demographic of the local district. And the scores for the ELA was 43%, and the mathematics scores were 32% at proficient level. That was actually higher than the other schools, by the way. So let's look at the classroom size. So the classroom size, I have 20 students, but 10 additional students come from different classrooms every Tuesday and Thursday. They come to my class, sort of like a rotation. So the class population is a representation of the local school district and the data. Why I say that? Because the class has 16 Hispanic students, 12 African American students, and 2 Asian students. So it matches the proportion of the data. So the results, and before I say the result of the experiment, I'm going to restate my research statement, my hypothesis, which is, does project-based learning generate a difference on assessment results versus the traditional instructions? Let's see what we find. So there's something called null hypothesis. Null hypothesis is like the opposite of your hypothesis. It's like negating your hypothesis. So if my hypothesis is project-based learning will make a difference in test scores versus traditional instruction, the null hypothesis would tell you what makes you think so. What makes you think that will happen? maybe it will not generate a difference on the assessment results. So I used P-test scores. So the post-test scores were analyzed to something called paired sample t-tests. So I compared the post-test of the project-based learning. So that was the results of the exam, the unit test that they took after the treatment and after the control. So after the experiment and after the comparison group. So what happened is I got the results. So let's first look at the results for the first post-test scores for the traditional instruction, and that's the mean. So it had a mean of 77.8, standard deviation of 9.66, and post-test scores for the PBL, which is project-based learning. So let's call it PBL. It was 86.5 with a standard deviation of 6.64. Again, you see the big difference in the scores, the mean for the test scores for the PBL strategy. Now, the t-test, it does something like this. So the difference of the two means were statistically significant because the probability is less than 0.001. So what that means is they have different figures. So they have something that's called the probability, the p-value. And it's actually, if you look at the table, I don't have the table here. It's in the sig two-tail. So that's where you find it. And so you have to test if it's less than, in my case, it's 0.1. But sometimes you have to test it against the 0.005. So this one is 0.001. So if it's less than that, it was really zero. So that means that you can reject the null hypothesis that says, hey, your hypothesis is not going to be proven. So you can reject it, and then you could accept something that's called alternative hypothesis, which is your hypothesis that, yes, it does generate a difference in test scores. Something does happen, it is significant. So let's look at the second post-test scores for the traditional instruction. Wow, it got much higher, didn't it? So it increased. So you have 82.5 with a standard deviation of 9.55. And the second post-test scores for the PBL strategy, 87.00. And the standard deviation is 7.45. So again, it was significant, statistically significant. So we can accept the hypothesis that PBL had higher outcomes in the tests. The conclusion that I got from this research after reading I'll talk a little bit about the literature review, because it's important to know that not all the literature reviews agreed with my research. Some of them had inconclusive results, and some of them couldn't test it because of validity reasons. And some of them, the data was not enough for them to make that conclusion. So not all the literature review agreed with my findings. Some of them did. Some of them had higher mean scores versus with the treatment versus the comparison, but many of them did not. So project-based learning, what I got is, it does help students on assignments and tests. It does give them a way for them to use real life applications in the classroom or wherever they are. So my research supported the research statement that research-based, project-based learning helps students on exam. And some literature reviews showed that it improves students' problem-solving skills. Some literature reviews showed that they had higher scores on formative assessments. But nothing is perfect. There were a few limitations with my research. The first thing was, so the students had to read 4 books. Obviously, they couldn't read the same 4 books. So although I tested if they were the same grade level, if the books were the same grade level, the same complexity, basically the same structure, would require the same amount of work, but how would I would need a better method of testing if the books are equal, if the books are equivalent in terms of complexity, in terms of content. It's not just enough that they are the same page numbers of pages, the same length. So that's important. That's another important limitation that wasn't really determined. Another limitation is students' attendance. Some students were absent. Some students were late. So that can affect the research, both under PBL and under instruction, the traditional instruction. Another one is, how do you know that the pretest was effective in measuring the students' oral language and reading fluency? So I would need to create a rubric to find out to find a better way to make those things more verifiable. So that's the limit. So thank you very much. It's been a pleasure, and I look forward to having future researchers.